In this video, we will solve systems of equations by the elimination method. The elimination method is exactly what it sounds like. It's going to be a method that will eliminate one of the variables. So the steps to solve are to make sure that the equations are lined up in the same form. The y has to be on top of the y, x has to be on top of the x term, and the constant has to be on top of the constant term. Step 2 is to add or subtract the equations to eliminate the variable with common coefficients. Remember, a coefficient is the number in front of a variable. Solve for the variable that's remaining. By step 3, we should have a value for one of the variables. And so after that, we need to substitute our answer from number 3 into either equation and solve for the other variable. And we're going to check our answers by substitution. All right, here in example 1. First, let's make sure step 1 is done for us. Here we can see that the y term is stacked on top of the y, the x term is stacked on top of the x, and the constants are also stacked on top of one another. So step 1 is done. Now for step 2, we need to decide which variable we're going to eliminate by recognizing the common coefficients. We see that the y values here both have a coefficient of 1, which means they have a common coefficient. So we have 1y and 1y. So would adding those or subtracting those eliminate the variable? So we know 1 minus 1 would give us 0. Our goal is to eliminate that variable, to make it go away. So here we see subtraction is going to be the way we make that happen. So we're going to subtract the two equations. Y minus y is going to give us 0. 3x minus 1x is 2x. Positive 4 minus a negative 2 is positive 6. Now we have an equation that we can use to solve for x. So subtract 6 and divide by 2, and we now know that x is negative 3. So now we move on to step 4, where we substitute our answer back into one of the equations. I just chose the first equation. So using that value of negative 3 that we found, we're going to figure out what the y is. So 3 times our x plus 4, negative 9 plus 4, and so our y value is negative 5. So our solution should be the point negative 3, negative 5. I also told you we're going to substitute in and check our answers. So our check here means we're plugging in our solution point to each equation to make sure it works. And it does. We see that we get true statements. This next problem is on your own. Notice that your x's both have a coefficient of 1. This one is also on your own. Notice that the x terms both have a coefficient of 3. Here, notice that the y terms here both have a coefficient of 2. In this example, we're going to once again solve by elimination. Notice that your x terms are stacked on top of one another, our y terms are stacked on top of one another, and also our constants are stacked on top of one another. So step 1 is complete. We also notice that our x terms have a coefficient of 4. But this time, one is a positive 4 and one is a negative 4. So we have to think about whether adding or subtracting those equations would make sense to eliminate that variable. So we have a 4x and a negative 4x. We want to eliminate these terms. So is 4 minus a negative 4 or 4 plus a negative 4 going to eliminate the variable? Well, it's going to be addition, because 4 plus a negative 4 is going to cancel that term away. If we were to subtract, we would get 4 minus a negative 4, which would be 8x, and then our variable wouldn't be eliminated. So from here, we're adding the two equations. 9y plus 7y is 16y. 5 plus 11 is 16. Divide by 16, so y has a value of 1. Substitute that 1 into one of the equations. Once again, I just chose the first one. So 4x plus 9 is equal to 5. Subtract 9 from both sides and divide by positive 4. So our solution should be the coordinate -1, 1. And when we check our work, we do get true statements at the end. Notice that the numbers for both equations don't have to be the same. We just have to have true statements. 5 is equal to 5 and 11 is equal to 11. For each one of these examples, make sure that you understand whether you have to add or subtract. Here, a -3 plus 3 would eliminate that variable. Notice here that the y's have a coefficient of 1, where 1 is positive and 1 is negative. Notice here that the coefficients of x are both a positive 7. So would addition or subtraction work for this problem? Okay, here. For this example, notice we do have the x's stacked on top of one another, the y's stacked on top of one another, and the constants stacked on top of one another, but they have to be in the same format. So notice where the equal signs are. They're not in the same position. So we're going to have to rearrange these equations in order to have step 1 done. So it's not enough just to have them lined up. They have to be in the same form. So our new system will look like x minus 3y equals 11 by just changing the first equation with subtracting 3y from both sides. Notice that the second equation did not change at all. So now we're ready for step 2. We notice that the y term both have 3's as their coefficient. We have a -3 and a -3. So would addition or subtraction work here? So we have -3 plus a -3 or -3 minus a -3. Which one of these eliminates the variable? Well, we know that it's going to be subtraction that eliminates the variable. This is the expression that gives us 0. Our goal is to make that go away. -3 plus a -3 would have given us a -6, and that's not what we wanted. So when we subtract, we have x minus 2x, which is a -x, 11 minus 16, which is a -5. We have to get rid of the negative so that x is a positive 5. Use one of the equations to solve for y. 2 times 5 minus 3y equals 16. So 10 minus 3y equals 16. -3y is 6, so y is a -2. So our solution should be positive 5, -2. And when we check our work, we do get true statements. So that indicates to us that we did it correctly. All right, we have a few more on your own problems. Notice here the equations aren't quite in the right format, so you're going to have to rearrange those equations. And I want you to think about here what you notice for the x coefficients and the y coefficients. What do you think is going to happen here? And in our last example, notice that the coefficients for x and y are the same, except different signs. So think about what's going to happen in those examples.